Okay, so again, if you're having to watch this from home, today is 428, and we're going to look at the last part of this unit. It's on electromagnetism, and today I'm going to look at 3 pieces of evidence that electricity and magnetism are intertwined. And with that said, let's go ahead and jump right into this. By the way, if you know anyone in SO, congratulate them on a good season. We have a couple people in here from that. And then esports also had a big competition over the weekend and so forth. So sort of a busy time, I understand. Someone else commented that the green paper over there is going through simple harmonic motion, sort of like the Tacoma Narrows Bridge did, by having some sort of oscillation being induced from some sort of driving force there. And you can sort of see that. It's like it must be that wind flow that's going, that airflow going through there. It's just like, just in a state of simple harmonic. It was, until we stop looking at it. Oh, now it's doing it again. Okay, so, anyway, there we go. A little simple harmonic motion. All right, Evan, you guys want to review for the exam right now? No. Oh my gosh, yes you do. Turn and tell that person that you're sitting next to, what are the 4 fundamental forces of nature? So you can do it. 4 fundamental forces of nature. Go. One of them is the thing that causes this ball to fall. What is it? Universal law of gravity. All right. What's another one? One more time. I didn't hear it. That's it? That's all we need is universal law of gravity? There's another one. Say it again. The nuclear force. All right. Nuclear force, you're only going to see the nuclear force if you split the atom. So the nuclear force is such a strong force and it's got such a narrow range. Keep going closer. You're never going to experience that thing unless you split the atom. What's another one? That's 2. What's another one? Thank you. The weak nuclear force. Unless you're involved in radioactive decay, beta, alpha emission, stuff like that, you're not going to even see the weak nuclear force. What's the 4th one, the one that we're studying right now? What is it? One more time. Say it nice and loud. All right, so we do not talk about the electric force in isolation from the magnetic force. And the reason for that is that electricity and magnetism are intertwined. So the 4th fundamental force of nature, the one that you saved for last, that's a nice idea since it's a good segue in today's discussion, is that it's electromagnetism. It's not electricity, it's not magnetism, it's electromagnetism. So these things are intertwined. So the first piece of evidence is that flowing charges, which is current, produces a magnetic field around a wire in circles. Now, if I had the ability to demonstrate this, I would. It's difficult to do this, especially with all the equipment that I have out for my 3rd hour class. But if I had a wire running through, in this case, sort of like a plexiglass, so that you could see down and above it, and I had current flowing through that wire, you would see a magnetic field sort of line up around that wire. And if I turn that current off, the magnetic field from those compasses would just line back up with Earth's magnetic field. So I can control the magnetic field around that by varying the amount of current. If I were to visualize that with concentric circles over here, I might put my thumb in the direction of conventional current. So if my right hand, the fingers would wrap around the direction of that magnetic field. And those magnetic fields almost look like electric field lines, except magnetic field lines always form closed loops, whereas electric fields could go off to infinity or come in from infinity. So magnetic fields always form closed loops. Now, if I take a long current carrying wire and I have the current flowing, let's see, I'd have the current flowing to the right. My fingers would point into the board and around. The current is sort of in concentric circles around that wire. If I were to make a loop, then I would intensify that magnetic field, always going, in this case, it looks like the magnetic field is coming out of the board and so forth, and so out of the board and so forth, out of the board and so forth, and so the magnetic field is very strong inside the wire, and it is all one direction. This is the key to understanding a lot of electrical equipment, is that we often use loops of wire to be able to intensify magnetic fields. One of the key applications is an electromagnet. In years past, I've tried to do a lab on electromagnets. Raise your hand if you've ever built one. Just a few people? Okay. I would rather have you guys build a speaker, which is like an electromagnet that's just constantly changing, and we're going to do that. I'm planning on doing that starting this Friday. I do want to take a moment. Sorry, you're going to have to watch this from home, I'm going to go over really quick the schedule because I think some people are going to be gone this Friday. I understand that this Friday might be another day that people are absent for a variety of reasons. Here's the plan for this Friday. We are right on track with the schedule, evidence of B&M relationships. I'm looking at that today. Tomorrow I'm going to look at force on the current carrying wire. I don't think I'm going to be able to do Faraday's law of induction as a lab. So this says Wednesday and Thursday. More than likely, I'm just going to show you Faraday's law of induction as a concept. I'm not going to try to do that lab so that we can then start on building a speaker come Friday. So I want you to be able to build a speaker. It's a multi-day operation where you're going to be building a speaker and then making various changes to that speaker to try to optimize it, make it work better. So if you're going to be gone on Friday, you're going to miss one of our work days for building this. This is usually about 2 to 3 days to be able to go through and do it. So if you're gone because you're whatever it is, I would expect you to sort of make that up. You should be a partner with someone else that's gone. So if you feel like you're going to be gone on Friday, I understand, have at it. You should partner with another person that's going to be gone on Friday so that you can work together to try to get things made up the next week, okay? Keep that in mind. I'm going to move the schedule a little bit around, and I'm going to not do that lab, and so we're going to move the speaker building up a little bit, okay? That's the plan. Okay. Going back to this. We can create a force on a wire. If I have another magnet nearby, I can generate a force on that wire. In this case here, I have current flowing through that wire from left to right. And if I have a permanent horseshoe magnet in here, I can generate a magnetic field around that wire by having current flowing through it, and then this thing can push it up. If I have the current flowing the other direction, I can pull that thing down. And so if I can generate force on a current carrying wire, I can use that force to be able to produce some motion. In this case here, it'd be a motor. And so I can make a motor using the fact that electricity can create magnetism. Now the video that I'm going to show you doesn't work well for recording of a recording. So I'm going to stop the sharing and I'll put a link in the agenda for this video that I'm going to show you. Okay, so let's go ahead and watch this motor, how it works.